Now remember, averages are going to vary sample to sample. So if we want to get an estimate of that population mean mu, we need to add and subtract a margin of error so we get a confidence interval. So here we're going to look at confidence intervals for mu. It's given by, the formula is x bar plus or minus t star s over the square root of n, where t star is looked up in the t-table for degrees of freedom, whatever the sample size, -1. And we want to have the population from which the sample is drawn to be normally distributed, or the sample size is large enough, and of course that 10% rule. But what we're focusing on here is n is greater than 40. As before with proportions, the results from a hypothesis test with a two-sided alternative will always correspond to a confidence interval if the significance level and the confidence level agree. So, for instance, if we decide to reject the null for a 5% significance level, we would not see the value of that parameter in the confidence interval for the 95% confidence interval. So continuing on with that sun protection factor, what if we did it as a two-sided test? So we're interested in is different. So this is two-sided, and we're going to say that it is 0.0383, and you're like, where'd you get that from? I did is I took the one-sided p-value and multiplied it by 2, the one-sided p-value from the applet. According to the p-value, is there evidence that the average SPF used by Cal Poly students is different from 30? Make it and state a conclusion at a 5% significance level, and how am I deciding? And I'm going to look at, okay, I'm going to look at the significance level, and I'm going to look at the p-value. Remember, as long as that significance level is greater than the p-value, we're going to reject the null. So we have evidence based on the p-value being less than 0.05 that the SPF for all Cal Poly students is different from 30. All right, so very similar to what we did earlier, except that now we're looking at a two-sided test. Determine a 95% confidence interval for the SPF, average SPF of Cal Poly of sunscreen used by Cal Poly students, and interpret the interval. Now, once again, we're going to start with the statistic, which in this case is x bar, plus or minus. Now we're going to need a t star. I'm going to leave some space for that. How do I get that t star? Well, I know my degrees of freedom in this case are 47. So if we're going down here, degrees of freedom 47, so I'm going to go to 40. And I'm like, well, how would I know though which one to use, what number? This is when you want to go to the bottom of the table and say, okay, I'm interested in that 95% confidence level. And here you're going to see there's lots of different confidence levels that you can predict, or that you can use to generate, or excuse me, you can use to calculate the confidence interval. And I'm going to go up to degrees of freedom being 40, and I get 2.021. And when I work that out, I end up with 30.29 to 40.29. So the interpreting should be very similar to what we did before. We are what level of confidence? We are 95% confident that the average SPF used by all Cal Poly students is between 30.29 and 40.29. Okay, so it's very similar setup to what we've done before, except that now instead of talking about proportion or percent, we're talking about the average. Now, looking to this, according to the 95% confidence interval, is there convincing evidence the average SPF of sunscreen used by all Cal Poly students is much different than 30, and how am I deciding? Well, I'm going to look at this interval, and I've got 30.29, and I'm looking at it compared to 30. Now, 30 is technically outside of there, but would you say that if 30.29 is, which it is, based on the confidence interval, is could be the true mean. Is that much different than 30? And the answer is no. 30.30 versus 30.2985 is not meaningfully different in these circumstances. Okay, so they're not meaningfully different. They are statistically different, but they're not meaningfully different. Suppose that for the sample of 48 students, the mean had turned out to be 34.29 and the standard deviation 17.19. How, if at all, would the 95% confidence interval differ from that reported in B? The margin of error in this case would not change, okay? All that we're going to do is shift this. Instead of 35, we're shifting it down to 34.29. So we're shifting this down, the mean down by the sample mean, excuse me, down by 1. So what's going to happen if we shift that down by 1? Well, then we'd end up with 29.29 to 39.29. Now, where does 30 fall? And hopefully you think, well, 30 falls in the confidence interval. So it would include the null. Same margin of error. Margin of error does not change. Remember, because that's using t star s over the square root of n, and we didn't change any of those. But it would shift 1 lower. Now, suppose that for the sample of 48 students, the mean had turned out to be 35.29 and the standard deviation actually was different and smaller. How, if at all, would the 95% confidence interval differ from that reported in B? So this is just getting us thinking. We spent a lot of time on confidence intervals before. This is just getting us thinking about if numbers were different, what would happen? Would the margin of error change in this case? Remember that margin of error is this right here. This is that margin of error. Does that change if our standard deviation is 16.19? And the answer is yes, it absolutely would. So instead of being 17.19, it would be 16.19. So if we have a smaller number up there, what's going to happen to this margin of error? Is it going to get larger or smaller? Well, let's think about it. S went down, so my margin of error is going to go down. All right, there's less variability as S decreased. So overall, what's going to happen is that confidence interval is going to be narrower. If you're struggling to see that, work through the numbers. Now, last one, suppose that for a sample of 58 students, so this case, excuse me, n got larger, the mean had turned out to be the 35.29 and standard deviation was 17.19, so those numbers didn't change from the original. How, if at all, would the 95% confidence interval differ from that in part B? Well, going up, what's going to change is here, we're going to be dividing by a larger number. So my margin of error is going to go down. So overall, it's going to be narrower. If you're having problems, like I said, seeing these, take the time and work through the calculations. Ideally, you get to the point where you can see this and not have to work through the numbers, but it does help if you're struggling with that, work through the numbers. Think about what's changed. In this case, S changed. In this case, N changed. And see how it affects that margin of error, which is there, and the overall confidence interval. And that wraps up the work on looking at one proportion.